Hello everyone, welcome to TryRide, the new era of learning. This is Pack 365. Today we're going to discuss in Module 2 local search algorithm in artificial intelligence. Let's begin the topic. Local search algorithm. Local search algorithm can be applied to solve constant satisfaction problems (CSPS) by iteratively improving an initial solution. This algorithm starts with a random or heuristic based assignment of the value to the variables and then move to the neighboring assignment that improves the objective functions. Example, reduce the number of violated constants. Hill climbing, simulated annealing, and genetic algorithms are example of the local search technique used for CSPS. Usually local search algorithm can be applied to solve constant satisfaction problems, right? By treating improve an initial solution, the algorithm starts with a random heuristic based assignment or for a value or variable and then move to the neighbor assignment that improves the objective functions and reduce the number of violated constants and hill climbing, simulated annealing and generating algorithm are the examples for the local search. In the assassin of the local search algorithm, all the class of optimization algorithm that starts with a potential solution to a problem and repeatedly try to improve it by making small incremental changes, right? Those explore the neighborhood of the current solution to the find the better one, aiming to reach an optimal, near optimal solutions. Here's a breakdown of the key concept of this. Okay, so construct satisfaction we all know. These are problems where you need to find a state or a assignment of a value variable that satisfies a given set constant, right? So, example you can take as including Sudoku and n queen puzzles like that. Iteratively moving an initial solution like local search algorithm do not try to find the perfect solution in one go, right? So, instance they are start with a raw guess and they gradually refined it. So in this we have random or heuristic based assignments, and we can see moving to the neighbor assignment and improving the object functions. In example, local search technique we use hill climbing, simulated annealing, and generative algorithms too. So local search algorithm. It may be it many optimization problems that path to be is irrelevant. The goal state itself is the solutions, right? State space equal to set of complete configuration and final configuration satisfying the constants. Example, n queen sums, we already discussed about it. Uh, in such cases, we can use local search algorithm too, right? Here we're discussing about in many of optimization problems, the path, the goal is irrelevant the goal state itself the solution the highly a key distinction for the local search unlike a algorithm that tracks a path. Local search in only concreted with the finding the final solution, not the step taken by the get there, right? So state space equal to set complete configuration. The state space refers to all possible agreements or assignments of the variable that could be potentially be a solution, or a complete configuration means that all variables have been assigned a value even if the configuration does not satisfy all the constants set. So finding the configuration satisfying like that, we can see this retrieves the primary goal to the find a specific configuration within the state space that meets all the defined constraints. That NQ problems is classic example where the objective is place n and chess queens and on the n into n like chessboard such that no two queens threaten in each other, right? So this point directly states the stability of the local search algorithm for the type of problem described above, where the path does not matter and the focus is on finding the satisfying the configurations only. Keep a single current or state that try to improve it. We have common search algorithm for CSP. So we have the most of the three types of common here. We have three types of common thing for hill climbing and simulated annealing and generic algorithm, right? So here we start first with hill climbing. Start with a random solution and rapidly moves to the neighbor with a better lower cost or few constant valuation until a local optimization reached algorithm. So it have starts with algorithm has starts with a random assignment of the value to variables and evaluate the current state number of violated constants and generate the neighbors of the current state and move to the neighbor with the lowest cost or the fewest constant violation if it's be better than the current state. Repeat the steps 2, 3 until no more improving neighbors can be found. So, and we can see first in hill climbing, before diving into the algorithm, let's briefly reinforce what is CSP's algorithm aims to. So, CSP defines the variables of a set of variables, right? X, we have variables X and domains D and constant C, right? So in the goal of a CSP is to find the assignment value of the all variables, one from each variable domain, such that all the constraints are satisfied. Local search algorithm or has discussed has the particularly useful for CSPs where the path to the solution is not important. Only the final state they work. Okay, iteratively improving a complete assignment. The objective function for the CSP in the context of obtain the number of violated constants. The goal is to minimize this to zero. So in this case, we take hill climbing algorithm too. We already in previous section we discussed about this hill climbing. So hill climbing is the simplest of the local search algorithm. It's a greedy approach, always moving towards a better neighboring state, right? So we can see that how it works. Initial state to it complete, but random assignment to of the work assignment really likely violates some object functions and neighbors is generated, it identifies and it changes the value another, and it has a greedy move for all the possible neighbor states, choosing the one of the rest in the greatest improvement, the largest reduction in violated constant it takes, and iterations like may choose the neighbor to the current state or repeat the process step 3 and 4 until the no neighbor state can improve. The objective found figure or the until a solution like zero is found like that. Variations we can say variants like in with the simple hill climbing and steepest ascent hill climbing and great improvement and we can say hill climbing randomly selection neighbor from the better ones. So we can see here problem defining an initial state to get stuck in a local maxima. So like the we have it with the best neighbor here. So in the n queen, we all know that n queen in a such of n queen problem, no all queens are treated as equal, right? So in diagonal, in vertical, in horizontal, no queens are treated equally. So they have a specific path to move any diagonal, vertical, or horizontally. Okay. So this divides into the hill climbing. So it little bit. So example of n queen, put the n queen on the n into n about with the no two queens on the same row, same column, or diagonal, right? So we arranging that we have the diagonal, so we can changing the locations of the queens, and finally we get a proper in the location of the queens. We did not match the even treated equally. So now come to the simulation. Introduce the randomness into the search to escape the local optima. It allows to move the word solution with a probability that decreases over time. So here we have algorithm. Start with the random assignment and the initial temperature. So evaluate the current state, number of the violated constants and its neighbors. So calculate the probability of moving to the neighbors based on the temperature and the difference in the cost. Moving to the neighbors with the calculated probability and reduce the temperature. And repeat step 5 until a stopping uh, criterion is met, right? Criterion a certain number, a certain number of the iterations are very low to the temperature. So simulated annealing is inspired by the annealing process in metallurgy, where metal is heated and then slowly cooled to allow the atoms to settle into low energy stable configuration. Right. So it addresses the local optima problem of the hill climbing by allowing the downhill moves with a certain probability, especially at the beginning of the search. So let us we can imagine some blindfolded person on the hilling landscape. Initially, when the temperature is high, they are willing to take steps that may downhill, right? It explores more. Has the temperature slowly cool, they become less willing to take downhill step and eventually behave like a hill climber, settle into the local maximum, right? Here the initial states. So we can take the initial state and temperature has start with a random assignment and the high temperature T. The temperature is to parameter that decreases over time according to the annealing schedule, right? So objective for function like same as hill climbing, typically the number of violated constants to be maximized and generation here randomly select a single neighbor of the current state and acceptance criteria like calculate the energy difference between the new state and the current state. So overall, the we can see annealing schedule a function that determines how the temperature T decreases over the time, and a slow cooling schedule increases the changes of the finding the global optimum, but takes more time. So iteration repeats three to five, two to five until a solution is found, okay, or a temperature drops to a very low value, or a maximum number of the iteration reschedule. So it has an advantage to uh, can escape the local optimum, making it more likely to find a global optimum. Like it also had disadvantages like requiring careful turning of the annealing schedules can be slow, it cooling schedule to be slow, like that. So once a prove, we can see already we have discussed about this. So we have the genetic algorithm. So in genetic algorithm, maintaining a population of solution and evolves them over the generations using operations like selections, crossover, the and mutations. This allows for the exploration of wilder such space and avoids getting stuck in the local optima. So algorithm we have initialize the population of the random solutions, evaluate the fitness of the each solutions, number of satisfied constants, select the fittest solution to reproduce, apply crossover combination parts of the two solutions and mutations introduce of the changes to create a new solution, replace the old population with the new one, repeat two, three steps again, satisfying the solution until we found a stop or a stop is a criterion is meted. So generic algorithm are inspired by the process of natural selection and evolution instead of the working with a single candidate solution like GAS maintains a population of the potential solutions and evaluates them over generations. Imagine like a populations of the different species of animal trying to survive in an environment. Those are the fitter are morely likely to survive and reproduce, passing the genes to the next generation. Over many generations, the population as whole becomes the better adapted. So how it works with initializing steps, it create an initial population candidates solutions like each individual is completed by the possibility involves assigning assignment of the values to those variables in those three CSP. These are obtained generally randomly. So each individual chromosomes is typically represented as a string of value, where each position is a string corresponding to the variable, and the value at the position is the assignment value for the variable, right? So, for example, we can take as for an n queen problem, the chromosome might be 3142, like we said, a list of 3142, meaning queen is the column 1 and at the row 3, right? So, queen in column 2 at the row 1, like that, etc. So, fitness, here the fitness function, define a fitness function that evaluation. So, how good each individual is the population. So for CSP, this is often directly related to the inverse of the number of the violated constants. A lower number of the violated constants means higher fitness. So we have the selection of the fitness solutions, right? So selection means it selects the individual from the current problems to become the parents for the next generation. Filter individually have the higher probability of the being selected. like this simulation survives all the fitness, like applying the crossovers like a selected parents made to produce an offsprings, like they involve a combination of genetic materials for the two parents. For CSPS, a crossover operations might swap the segments of the values assignment between the two parent chromosomes. For example, parent 1 and parent 2, like we parent have one list 3, 1, 4, 2, and parent 2 has 2, 4, 1, 3, like an example list. So we can take offspring has 3, 1, 1, like that. We combination of both variables we can take. Like randomly alter the small portion of the offspring genetic material. This introduces a new variation into the population and helps prevent the algorithm from getting stuck in the local optima. For the CSP, mutations might be involved randomly, but changing the value single variable of the offspring assignment to the those. So it a new population, the new offspring from the next generation. Iteration repeat until 2 5 for the fixed number of the generation or until satisfy or satisfactory solutions. Okay, is this found? So in this we have advantages too in genetic algorithm. So can explore a large range of large space efficiently, like less prone to getting the stuck in the local optima, and population based approach the crossover mutations highly parallelizable. And disadvantages too we have, we can say that can be expensive due to the maintaining and evaluating population, like we have requires careful turning of the parameters like population size, mutation rate, and crossover rate. So these are the simulated annealings and hill climbing. So overall, my conclusion in summary is three of the aim solution. Overall, we have the solutions like we can say that. So hill climbing is a fast but prone to a local optima, and simulated annealing is to improve the hill climbing by allowing bad moves to escape the local optima, guided by a temperature parameter, right? So genetic algorithm use it to population based on evolution approaches with the selection, crossover, and the mutations to explore the such space broadly and find robust solutions of the often the good on very complex cases. So I hope you guys all are understand about the topic of local search optima, about the hill climbing and simulated annealing and genetic algorithm. So that's for this section. Thank you all.